There is a memory stick in your course bag that contains the lecture material, the exercises, the input files that you need for doing the exercises, and also the ORCA executables. So if you haven't set up your computer yet, you can do it with the memory stick right before the practical course.
My name is Vera Krewald. I am studying chemistry at the University of Bonn in the 8th semester.
I'm Jeff Harmer from Oxford University, and we have a new EPR centre in Oxford called CESAR, and I'm the manager of the EPR centre.
My name is Panida Surawattanawong. I am a postdoc at Max Planck Institute for Bioinorganic Chemistry.
A unique feature of this summer school is that there are as many as 5 different research activities who came together to make the summer school.
I'm from SFP 624. I come from the University of Oslo.
I'm coming from the University of Heidelberg, from the Graduate College organization.
I'm from the University of Antwerp, but financial support is from the CostP15 action.
So you see already from the titles of these coordinated research programs that it's very diverse, and that already tells you how powerful the methods of theoretical chemistry are, that they connect all of these different research activities that just taken face value have nothing in common. But in reality they have. And to show these connections between the different research fields, that's a unique feature of the summer school.
I think it's interesting to meet different people, because lots of people who came here to visit the summer school are experimental chemists. So they have a completely different background and approach.
The aim of the summer school is to provide experimentalists with a working knowledge of how to apply theory to solve their everyday problem. The participants will learn the connection between the actual experiments they do and the quantum chemistry to describe these experiments. So the major theme of the summer school is to make the connection, the link between theory and experiments. People doing experiments, and very sophisticated experiments, and the outcome of these experiments is very often very difficult to understand. And this is why they need the tools to interpret their data. This is the major aim of most of these people. But there are other aims. For example, there are things you just cannot measure because it's too complicated or too expensive to measure them. And then you can use theory to fill in the blanks where you cannot have experimental information. So you get a much more complete picture of the systems you are studying when you use theory.
So I'm coming from experimental magnetic resonance. And the motivation is to correlate experiment and theory.
Actually, I want to learn ORCA program to use my research. That's why I came here to learn.
To learn more about this, because I do spectroscopy, I do structures, and I also started to do calculations on these things. So for me it's the perfect course, I would guess.
The motivation for doing such a summer school is always multifaceted, and the first and most important reason is that it's a very large amount of fun to interact with young people and young researchers and guide them a little part of the way. That is, I think, the guiding theme, and if I wouldn't enjoy it, I wouldn't do it. But then, of course, the SFB is not only a research thing that the DFG funds, but they want us to invest in advanced education. And such a summer school is an instrument of advanced education, of course. And third of all, my group and me, we put more than 10 years of effort in developing the ORCA program, which is one of the major quantum chemistry program packages today. And so we want people to make use of all of our efforts. And in order to make people use it, they have to know about it. And so what we do is we teach them here how to use these very powerful tools to solve their everyday problems. And so we hope that they benefit from it, and so our efforts become more useful for a larger community.
Be able to run the ORCA program for open shell molecules. And probably it's fair to say that Frank Nieser is maybe the best, or at least one of the leaders in open shell calculations. So it's a good motivation to use his program.
The design of the summer school is as follows. So we want people to get their hands wet, so to come to the actual practice of theoretical chemistry, but to also understand the theoretical background. We have structured it in a special way. We have basic lectures about theory in the mornings, and we have practical work at the computer in the afternoons. So people can directly practice what they learn in the mornings. And of course, we have a very large variety of people of different backgrounds, ranging from hardcore physicists to biochemists. So we have to reflect the different levels of knowledge that they have about theory in the design of the course, and that's why we give specialized lectures for those who are particularly interested in the afternoons as well. And the final thing we do to encourage interactions between the participants of the course is that we have 2 poster sessions in the evenings where people present their own research, and so they are supposed to discuss with each other their result. I think that is a good mixture between teaching them basics and letting them make their own experience with the methods that we're talking about.